Welcome to our project, Indoor Drone Communication. This project aims to establish a wireless communication system between an indoor drone and a Raspberry Pi, allowing real-time sensor data retrieval over a local network. The drone's sensors collect data while flying, and this information is transmitted to the Raspberry Pi, which publishes the data wirelessly to the local network. The Raspberry Pi acts as a middleman for publishing the data to a ground station, in this case a laptop, which will then display the data on a user interface. And so why is it important to establish a communication between our drone and the ground station? Well, oftentimes you're going to be performing high-level processing such as machine learning, visual SLAM, and visual geometry. To do this, we need to be able to take the sensor readings from the microcontroller and send it to the Raspberry Pi, which will then act as the communication hub to send it over to the local network using sockets. And so here's our setup for the Raspberry Pi. We have the Pi connected to a lithium-ion battery and a buck converter. This acts as our power source. On the top, we have our microcontroller that does our low-level operations and obtains our sensor readings. Once we have our sensor readings, such as our altitude, our gyroscope with the angle and rates, we send that over using USART as our serial communication protocol through the RX and TX pins. It is then received on the Raspberry Pi, which will then publish the information through sockets to our local network. From there, we can go to our ground station, which is our laptop in this case, and we can read the values that are transmitted as JSON and be able to view them on the screen in a graphical format. Here you can see our roll, pitch, and yaw angular rates, which are obtained from our gyroscope on the drone. And as you can see, these values are real time. So if I want to pitch the drone to the left, you can see the very top graph is responding in real time. If I'd like to go in this direction, you can see another axis changing. And if I would like to yaw, you can see this is also changing as well. And so this concludes our project. This could be extended to other sensors and other measurements, such as optical flow sensors, surveillance cameras, and other means of sensing. Thank you for listening.